Okay, we are getting ready. Actually, we're going to start chapter 11 right now. Chapter 11 is an extension of chapter 10. And the key difference, we're still going to use the hypothesis testing process. In chapter 10, we took mean data from one sample and compared to some hypothesized mean. And we did that using situations in which the population standard deviation was known, in which case we used the Z distribution. And when it was unknown, we used T. Okay, as we get into chapter 11, it's a little more sophisticated from the standpoint that we're going to be taking data from two different samples. And I'm going to probably have three different mini lectures here, mini recordings. The first one's going to be the most basic. And here we're going to look at the two sample test of population means when the population standard deviation is known. And to calculate that, we're going to use the same process that we did in chapter 10 when we calculated Z values. But in here, we're going to take the mean of group 1 minus the mean of group 2 over the square root of the variance of group 1 divided by the number in that particular sample plus the variance of group 2 divided by the number in group 2. So anyway, this is going to be the equation. This is on page 350 of the textbook. And probably the best way to do this is to go over one of the problems. And we're going to look at number 4 here, which is on page 354. As part of a study of corporate employees, the Director of Human Resources for PNC Inc. wants to compare the distance traveled to work by employees at its office in downtown Cincinnati with distance for those in downtown Pittsburgh. A sample of 35 Cincinnati employees showed they travel a mean of 370 miles per month. A sample of 40 Pittsburgh employees showed that they travel a mean of 380 miles per month. Population standard deviations are Cincinnati and Pittsburgh are 30 and 26 respectively. We've got a level of significance of 0.05. Is there a difference in the mean number of miles traveled per month between Cincinnati and Pittsburgh employees? Here, if we're just asking for if there's a difference, that's going to be a two-tailed test. If we asked whether the Pittsburgh employees rather were driving more, that would have been a one-tailed test. Here, we just want to see if there is a difference. I'm going to go ahead and switch this over. I've already worked this one out, so we should be able to go through this one relatively quickly. You'll see that the null is going to be that the mean of Cincinnati is equal to the mean of the Pittsburgh employees. The alternative, not equal. Again, we've got a two-tailed test. And for this one, we have a level of significance of 0.05. So we're going to simply take, this is our equation. We're going to take the mean of Cincinnati, subtract from that the mean of Pittsburgh. That's 370 minus 380. And in the denominator, we're going to take the variance of Cincinnati, which was 30, square that over the number of Cincinnati employees, which was 35, plus for Pittsburgh, we're going to take this 26 squared, divide that by 40. There were 40 employees there. And once we do that calculation, we're going to take the square root. So I went ahead and worked this one out. And once you do that, and I would encourage you to go ahead and work this out, make sure you come up with the same values. You should come up with a calculated Z of negative 1.5319. Again, we're using the Z distribution, alpha 0.05. So by now, you shouldn't be aware that our critical value is going to be plus or minus 1.96. We came up here negative 1.53. We are not in rejection area, so that we will say that the difference in the number of miles traveled, there's no difference, that 10-mile difference is simply sampling error. Or put another way, we cannot say that difference of 10 is great enough to be considered to be statistically significant. So when you go ahead and for this one, when you get the smaller portion for the Z value of 1.53, that should be 0.063 because this is a two-tailed test. Remember, we've got to double that, so we get 0.126. And again, now this p-value was not asking the question, but I wanted to show you how to calculate that. So again, this is how you do Z-test rather, when assuming the population standard deviation was known. So this is Z for two independent groups. So hopefully this helps, and we'll have another video posted shortly.